So hello everyone. So in this session, we will see about an graph traversal algorithms. In today's session, we will see about an breadth first search and then followed by depth first search. So traversal. So what is the traversal? Visiting all the nodes. Visiting all the nodes at least once. That is called traversal. So in the breadth first search, we will use an queue. In depth first search, we will use an stack. So at first, we'll go for breadth first search straight away. So here, there's an algorithm. So define a queue of size, total number of vertices in the edge. Suppose if there are 5 number of vertices are there, then we will fix our queue as a 5. And then you can start from any vertex you want. Okay, it doesn't need to be from A or it doesn't need to be from 1. It can start from any vertex. And then as you visit the vertex, we will insert into the queue. We will insert into the queue. And then once you visit the vertex, we will visit all the adjacent nodes of the corresponding vertex. So now the same steps we will perform through example. So then it is easy for us to understand. So now here this is the graph. This is a given graph A, B, C, D, E, F, G. So I have taken A as a starting point. A as a starting point. So for A, insert A into the queue. For A, the adjacent nodes are B, D, E. So I will insert into the queue. So D, E, and B. So then visit all the adjacent vertices of the A, which are not visited. So now what happens over here? We have visited the D, we have visited the E, we have visited the B. Okay, so now we will take the D. We will take the D next, and the Q is in the D. So now for the D, all the adjacent nodes are visited. A is already visited. E is already visited. E is already visited. So we will delete the D from the queue. So then in the vertex, what do we have? We have an E. So for E, what are the adjacent vertices are there? D is already visited. A is already visited. B is already visited. So C and F are pending. C and F are pending. So I will add a C and F. I will add a C and F. So C and F are visited. C and F are visited, and I have added in the queue. Then in the queue we have a B. We have a B. So for B, the adjacent nodes are A is already visited, E is already visited, and C is already visited. So we can delete the B from the queue. So then we have deleted the B from the queue, and then next in the node is going to be C. For C, B is already visited, E is already visited, F is already visited, only G is pending. So we will add a G in the queue, and then we will visit the G also. So we have visited the G also. Next in the queue is going to F. For F, E is already visited, C is visited, G is already visited. So delete F from the queue. G, C and F are already visited. So every vertex has been visited. So the final breadth first search, the spanning tree, a minimum spanning tree. A minimum spanning tree is nothing but uh, the connection between all the vertices. Connection between all the vertices. Okay, since we don't have any weighted over here, it is a connection. So there is a connection between all the vertices in this graph. That is called minimum spanning tree. So this is the BFS, breadth first search algorithm process. Okay. So a breadth first search is nothing but we will use it as a queue. We will use it by using queue. So in the queue, we will take the number of vertex size. If there are number of vertexes going to be 5, then we will take graph size as a 5. Say a queue size as a 5. Then we will start from any node, and then we will visit that node, and then we will visit the adjacent nodes of the corresponding vertex. So likewise, we will keep on repeating the same step again and again until all the vertices are going to be gets visited. Okay, thank you.